Good evening, everybody. Welcome to Second Home. Thank you all for making the effort to be here. This is our second edition of the Polkadot London community, and we're still very much in the inception phase. So it really means a lot to us that you're all here. We're really bootstrapping the community in London. It's going to be one of our flagship communities, and we're really looking for as much collaboration and participation as possible from everybody. So if you, we're going to be here once a month, and if you in any way want to get involved with the co-organization, or you're working for a project that fits into the ethos of what Polkadot is doing and into the Web3 movement, please come and work with us. We've got some great speakers here this evening, but we are always looking for more volunteers. I wanted to kick off just with a couple of community announcements. So before I start, I'll introduce myself. I'm Josh, and I'm helping build the Polkadot community. We've got some other of the core members of the team here this evening, both technical and non-technical. In terms of the speaker lineup, I'm sorry we're running a bit late, but Jack Fransham from Parity Technologies is going to kick off. He is a core developer at Parity and has been a key developer on the Substrate initiative, which forms a key fundamental component of Polkadot. And when we were last here, a lot of the community members we spoke to wanted to really hear about this new and exciting technology. So Jack will kick off, and then Richard Muirhead, who's the founding partner of Fabric VC, one of the leading VCs in the space in London, focused on investing in decentralized protocols. So if you again are working on a project and you're looking for funding, then you should try and grab Richard while he's here. Thirdly, we have our resident godfather of finality gadgets, as I like to refer to him as, Dr. Alistair Stewart. We're going to hear about his latest invention, which is really, really exciting. So I won't put any spoilers on that one. And finally, Francesco, who is the CTO of Applied Blockchain, one of the sort of key advisory companies in London. He's also the technical lead for a new protocol called Fern, which I'm really looking forward to hearing about. So that's the lineup for this evening. In terms of what else do I need to talk about? So we're hiring quite aggressively at the moment. So if you are either, we're looking for 3 key new members to join the team. The first is a community manager for Polkadot to help build the community. We were in Zurich last week, Rotterdam yesterday, we're in London today, and then we're also hosting an event in New York tonight, San Francisco next week, and LA the following week before we go to Asia. So this is really the moment to get involved right at the outset of building the Polkadot community. We're also looking for a decentralized, what is it, Al? Decentralized protocols researcher as well. So if you have a PhD after your name, we'd love to hear from you too. And finally, we're looking for a social media manager as well to help with our socials promotion. The last thing that I will mention before handing over to Jack is probably our largest community gathering and the first of its kind, which is the Web3 Summit, which is taking place in Berlin. You can see some details behind me on the 22nd to the 24th of October. And we think this is a really unique production. We're really trying to change the way that blockchain conferences have been put on in the past. We will have 1 track for speakers and then 2 community-driven spaces. One is the hackerspace, which I'll be curating, which will be built up of 10 individual nodes, and each node will work on a different theme of decentralization over the course of 3 days. Now, whether that's art, design, nature, all sorts, there's a real plethora of opportunities there. So, and finally, we have the workshop space as well. So We're really trying to engage with the community, and if you are free, it's the week before DevCon, definitely come and participate and pay us a visit. And with that, I'm going to hand over to our first speaker, Jack. So if you all give him a big hand, that'd be appreciated. Thank you.
Hi guys, I'm Jack. I'm from Parity Technologies. We are the development team behind the sort of flagship implementation of Polkadot. And I'm here to talk about the main technology underlying Polkadot, which is our blockchain development framework called Parity Substrate. Okay, how many of you know what a blockchain is? Hands up. Yeah, okay. How many of you have used a blockchain product of any kind, like semi-regularly? Like, yeah, that's still quite a few. That's a lot more than when I asked this question before. How many of you have built a blockchain? Hey, got some hands. Okay, this is like a lot more technical than last time I gave this talk. This is great. Clicker didn't work. Hey, oh, blockchains are rubbish. I don't know how many of you agree with this, but I definitely feel this very, very strongly. So there's many problems with blockchains. For the first point, like most of them are pretty like very, 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 very slow. Getting a transaction, I mean, obviously Bitcoin is a pretty bad example of blockchains in general, and it's pretty unfair to compare everything to Bitcoin. But I'm going to do it because it makes Substrate look better. Like if you want to confirm a transaction on Bitcoin, it can take hours, and especially at like times of high load, even longer. And other blockchains aren't much better. Probably like the fastest sort of proof of work one that's out there right now is Ethereum. There's probably others that are faster, but that's the one that I use the most that's like relatively fast. And even that, like it's a very long time to get your transaction and have enough confirmations that exchanges will accept it. More than that, they're horribly inefficient. Like most blockchains nowadays, there's another point further down about this, are literally just like moving numbers around, adding and subtracting, like really basic accounting, and the amount of power that they use to do this is absurd. Like the amount of power that your CPU needs to do an addition or a subtraction is barely measurable, but blockchains use hundreds of tens of billions of thousands of times that. So what I was talking about having enough confirmations that an exchange will accept a transaction, you can never be 100% sure that a transaction cannot be reverted. So the reason they do that is so that they want to be sure that your transaction can't be reverted because some other chain has been found, which is longer and doesn't include this transaction. They just want to be sure of this. But you can never be 100% sure. You can be 99.99999% sure, but you can never be 100%. You can't really upgrade a blockchain at all. You can deploy a new blockchain and just call it the same name as the original, but the original one's still around. Like the blockchains are essentially copy on write. Like if upgrading a blockchain is just telling a bunch of people that now this new client, this new blockchain, which retains the history of the original, it should now be called Ethereum or should now be called Bitcoin. You can't upgrade it in the sense that you upgrade a piece of software on your computer, for example. It's really hard to build them. I mean, like even though this room had a lot more hands go up when I asked who built a blockchain, it's still a tiny fraction of the room. Even like I'm sure a bunch of you are developers but have never built a blockchain because it's really hard, especially like a production grade one. And kind of because of these 2 points, I'd use the laser, but it's a screen. The movement, the pace of innovation in blockchain is really slow. Honestly, I mean, we are. Remove that point. We are like mostly still stuck in like the first generation of blockchains, which is the basic accounting blockchains. We don't really have, I mean, I would consider generation 2 to be blockchains with smart contracts, and most blockchains don't have that. It's kind of like related to this hard to innovate. It's also related to the fact that there's not really that much code reuse. It's hard to like create like a reusable smart contract library that's used between different chains. You really, if you want to use Ethereum smart contract system, you have to use everything else in Ethereum, or at least you have to build it on top of an existing Ethereum implementation. There's not really much like libraries that can be reused between people unless you reuse everything. Like you basically fork an existing chain in the GitHub sense, not in the blockchain sense. That's confusing. If you want to build on top of their code, it's not really like a library. And yeah, so this one. We're mostly still stuck in the first generation. So, there are other problems with blockchain, of course, but I didn't mention them because Substrate doesn't solve them. Substrate, by default, is very fast. So you can make a slow chain with blockchain, but with Substrate. But whereas with proof-of-work chains and something like Bitcoin or Ethereum, where you have to work pretty hard to make it efficient and fast, you sort of get, by default, a fast chain with like reasonable confirmation times and so forth with Substrate. More than that, this is a bit of a wishy-washy point. This is a very good point. It's much better. So, in a proof-of-work chain, even if you discard like the extra work that you're doing to calculate the proof of work, you still have people racing to create a one block. So that means if you have 100 miners on a network, that's not even like something like Bitcoin. People say it has like 10 miners. That's only like 10 miners actually receive a reward. I'm not talking about that. I'm talking about everyone who's mining, whether or not they actually get any reward ever. If you have 100 miners, you're using 100 times the amount of energy and doing 100 times the amount of work to create any given block, because 100 people are doing it. And that's completely, and you normally have much more than that, orders of magnitude much more than that. With Substrate, I'll get to this, you only do, only one person creates any given block. You still have like extra energy use for verification, but that's kind of unavoidable in a decentralized system. So the finality is 100%. It's not 99.99999%, it's 100%. Substrate isn't the only technology that gives you this, but it's the only one that I'm going to tell you about. You get, this is really good, and I've got an entire slide on this. You get upgrades in the traditional sense. You get actual upgrades, not just new blockchain wearing the skin of the old blockchain upgrades. For simple chains, this is also something I'm going to talk about way later. You can build them very fast. You can sort of start with a basic foundation. If you want to build like something that just has accounts and balances, for example, and maybe a proof of stake chain that just has accounts and balances and is permissionless, you can do that very, very quickly. Like maybe that you could do in hours, not even days. But like blockchains that you're building that have your own actual USP, that could be built in weeks, maybe. You'd still need like good mathematical proofs of it and whatever. Like, don't just stick it out in the world and say that it's worth $1 billion. And unlike when you GitHub fork a blockchain code base, and people like change all kinds of stuff, they like break things, tear things out, whatever. They don't really care about you. With Substrate, because it's a library, it has a very well-defined interface, and we can iterate on it and understand when people are going to need to change their code, completely independent of what's running on top. In fact, Polkadot, which is built on Substrate, it doesn't follow the development of Substrate exactly. Like every now and then, we pull in the new changes from the latest version of Substrate, and Substrate is being worked on by a different team, in fact, at this point. Kind of. And because it has a very well-defined interface, you can build reusable libraries that you can use in more than one different blockchain. It's not just like you can build something that only works with something that is on this code base. And because of this mostly, we have a smart contract library that's in development right now that you can pull in, or someone else can make a smart contract library that you can pull in. It makes it a lot easier to build these second generation blockchains rather than just having to do everything on the EVM, which is pants, as someone who works on Parity Ethereum. So the efficiency thing, this is based on like a POA style consensus algorithm, or a consensus algorithm that is I'm sure Al doesn't like that I'm calling this a POA, consensus algorithm. But essentially, we have a set of we have a set of authorities per block, and one authority is chosen to create that block, and then signatures from the other authorities are collected, and when 2/3 of those authorities have signed this block, then it is considered final. So 2/3 is a super majority. I'm not going to go into exactly why it's 2/3, just take my word for it. Because only one person is creating any given block, this is super efficient, especially compared to like a mining style system. It also, you get 100% finality, because so the reason you can't have 100% finality in a pure proof of work system is because essentially the way you get finality is when a majority or a supermajority of the people who could, in theory, verify this block have verified this block. The thing is, in a pure proof of work system, the way you verify a block is you build another block on top of it. And anyone can build a block. Anyone can build any given block. And this basically means that there's no such thing as 2/3 of the number of people who could validate this block, because the number of people who could validate this block is infinite. It's actually, I think I'm sure Al can tell me whether or not this is true, but I think it's like not possible at all to have finality with a pure proof of work chain. It has to be like combined proof of work, proof of authority. And because the authorities are chosen per block, not for the whole chain, you don't just have to do this proof of authority chain. If you know, hands up who knows what proof of authority is. Like, okay, so you can choose the authorities based on like a weighted random choice of the stake, or something based on whether people are staking or not. And this means you can build like a proof of stake system. So proof of authority is sort of semi-decentralized, federated, distributed, whatever you want to call it. It's not like completely permissionless like a proof of work chain might be, but proof of stake is completely permissionless, and you can build it with proof of authority as a primitive. So, building a chain with Substrate, basically we have this concept of a runtime, and the runtime is the thing that the blockchain does. For some definition of does. I think a lot of like blockchains kind of muddy the water when they advertise themselves as like maybe they advertise themselves for having like faster transactions, like it's just Bitcoin but with faster transactions or so forth. But the sort of state machine, the actual thing that the blockchain actually does, that's separate. So all UTXO chains have the same runtime, although they wouldn't separate it out into a runtime. It's basically the thing that the blockchain does completely, if it were completely separated from the networking, completely separated from the consensus, all of this stuff. When you build a chain with Substrate, it is the separation between the runtime and the rest of the client is strictly enforced. And this doesn't sound like completely mind-blowing, but really it means we can do a lot. It means we can do a lot, give you a lot of special powers, basically. And the most important one of these, a major power here, is upgrades without forking. So because the runtime is separated, and because we use Rust, we can compile this to WebAssembly, which is basically a completely platform-independent instruction architecture. And it's basically like running the blockchain's logic in a virtual machine. Because of this, you can have the government choose whether or not a new upgrade is desired. And in fact, recently, we had what as far as we can tell, is the first ever on-chain governance-based upgrade of a blockchain in the history of the universe since the Big Bang. I mean, I'm sure aliens don't have a concept of a blockchain, so we can say that. And so the way this works is, because it's deployed on the chain, if you have an old client, if you haven't upgraded your client, you just use the virtual machine version. And then if you have upgraded your client, then you can switch to a native version that just does the same thing. So you still get the same speed as if it was, you always required an upgrade of the client. You know, the same way that like with Ethereum, if you want to keep accepting the new Ethereum blocks, you have to upgrade your client in advance. With this, you don't have to upgrade your client in advance. You can upgrade your client whenever you like, and old clients that aren't upgraded will still accept the new blocks and still be able to work with them, even though they might not be as fast and they might not have like the new upgrades to the networking, for example. And because like the runtime chooses how the runtime upgrades, which means you can get the government to do it. I mean, like a simple governance mechanism for this would just be, if it's signed by the developer, always accept it. That would be like a really simple one. But in Polkadot at the moment, we have like a pretty basic coin vote where you can delegate your vote to someone else. That's probably not what the governance is going to look like when we release it, but that's what it looks like right now. And you can have any system of government, but also you can like have any system of upgrades. You don't have to have anything in the runtime upgradable. At the moment, we upgrade the entire runtime, but you could, if you like, have it so that only certain things about the runtime are upgradable. You can only tweak certain things. You know, it's like a crypto constitution of sorts. And there you are. I can wave this like a magic wand. I didn't have this before. You can get upgrades without hard forking at all. It's just it's actually an upgrade and not just a hard fork where people keep using the same name. A second thing is this sort of... Okay, so I've written light clients. Obviously, light clients exist for non-Substrate chains, but light clients in Substrate are a little bit special. So if you don't know what a light client is, basically, it's light clients that are clients that don't pull the whole blockchain. They don't verify everything. They pull the headers and can verify that the headers are correct. And then when they need part of the state, they ask a node for the state. The node can't just tell them whatever the bloody hell it wants, because it has like cryptographic proofs to make sure that the state in the header, the hash of the state in the header represents the state that they've been given So it's still secure, but they don't verify the whole chain. So you couldn't have a chain made entirely up of light clients. But anyway, yeah. With Substrate, light clients can be run in the browser. This is something that is not really possible in most things right now. So we have this networking layer called libp2p. It's based on IPFS. I'm not sure how many people know what IPFS is, but we've written a re-implementation of their networking layer, which is sort of agnostic. So it works over TCP, it works over WebSockets, it works over Unix sockets if you're a nutcase. So yeah. And because the runtime is already WebAssembly, this means that we can sort of run it in the browser very efficiently, because we can just use the browser's WebAssembly runtime. And this means we can have something that looks like a hosted wallet, something that's as usable as something like the now defunct wallet.parity.io or Coinbase or Kraken. Obviously, those are more than wallets, but like it's as easy for average Joe Schmo doesn't know what a blockchain is to use, but it is significantly more secure. You're not communicating with a trusted third party. You are doing everything on your client in an efficient way. Plus, there we go, second time lucky. You can run now, because we have this fork-free upgrade mechanism. Light clients also get access to this. Something that you can't do at the moment is have a long-running light client. You can't have your fridge tell you the latest doings on the Ethereum blockchain. You could have it run a light client that works now, but when Ethereum hard forks, I mean, do you think your fridge manufacturer is going to upgrade the Ethereum client? No, they don't. They can't even stop Mirai, which like the bugs in that would be years old. Whereas with the Substrate light clients, because the upgrades are done on-chain, the light clients that are really long-running, that never get upgraded, they still stay up to date with the blockchain. They can still produce the same information. So as I said before, Polkadot is built on Substrate. So Substrate is just a framework for creating blockchains, but also, so Substrate is built, Polkadot is built on Substrate, but also Substrate chains can run on Polkadot, will be able to run on Polkadot. So essentially, Polkadot parachains have to have certain constraints on their finality. They have to have it for a start. So something like Ethereum can't run unmodified on Polkadot. But if it's a Substrate chain, by default, it satisfies these kind of finality constraints, plus it also satisfies the API you need. The information that Polkadot needs is available in Substrate chains by default. And in fact, we want to have like a compilation mode. So you just take your Substrate runtime, you press a big red button, and voila, it's on Polkadot. That is still in the planning stages. That doesn't exist right now. So, because currently blockchain and cryptocurrency are basically synonymous, the technical level in here seems a little bit high, so probably you guys know that it doesn't have to be. But for now it kind of has to be, because there's really no reason to run a blockchain with all of the efficiency problems and speed problems and usability problems, unless you're making fat cash off it, unless it's really earning you a lot of money. But with sort of massive efficiency improvements and also abilities to create and also how generic Substrate is, where you don't necessarily have to have transactions on your blockchain. I mean, so a blockchain really is just it's similar to event sourcing, it's similar to Redux, it's similar to all these things. It's just a list of messages and state that can be changed in reaction to these messages. So you can build all kinds of things with it. You don't have to build a cryptocurrency. The state doesn't have to be accounts and balances. The messages don't have to be send money from Alice to Bob. I mean, you could build a social network on this, maybe like a federated social network similar to Mastodon, where I don't know, the authorities are the moderators and they can choose whether or not transactions get through. You can make a instant messenger with maybe somewhat verifiable sending guarantees, or maybe that it's uncensorable. Obviously, the instant in instant messenger here is a little bit fuzzy, because as fast as Substrate chains can be, they're still not instant. You could build a market. That's where I do the evil Monty Burns fingers. I'm not going to go too deep into that one. So if you want to learn more about Substrate, and you definitely do, guys, it's you can come to the Web3 Summit in Berlin. This is around the same time as DevCon in Berlin, I think. Is that the case? Can you tell me? Right. Oh, in Prague. Okay. So it is, October 22nd to 24th. We've got a talk on Substrate by the man himself, Gavin Wood, sort of introducing Substrate properly. We've also, you didn't hear it from me, but we may possibly kind of have a workshop where you can build your own chain on Substrate in a few hours. But yeah, you're not allowed to tell anyone about that. It's a secret. We've got loads of other cool stuff as well that I didn't commit to my brain banks because it's not important for this talk. And thank you very much. If you want to look at the code, it's here. Oh, it's heard claps. Not yet, not yet. If you want to look at the code, it's here. If you want to go to the Web3 Summit webpage, it's this one here, and you definitely should. And now you can clap. Okay, thank you so much. Thank you. Are there any questions? No? No questions? Oh, hello. Do we have another microphone?
Hey, thanks for the talk. So I'm not too familiar with proof of authority, but and maybe you touched on it, but how do you select, how do you randomly select the leader for the particular round during a block?
Yeah, so this is an ongoing research problem. In fact, I was just talking about this today. So yeah, randomness in this sense is quite difficult to quantify. I mean, there's proof of authority systems like Aura, which just cycle through the authorities in order. But having it be predictable is not is a bad thing, because if it's predictable, then you can. Well, if it's manipulatable, then you can make yourself the authority, and if it's predictable, then you can like insert yourself in a certain place and then make someone else look offline, basically, and get them slashed if it's a proof of stake system, for example. There's like a few different ways. Basically, you can like have certain cryptographic methods to make something random enough so you can only predict it one block in advance, and that's like good enough. But it can never be totally random.
Okay, but even if it's one block in advance, couldn't you just then attack that leader in that block?
I mean, if you're like a nation-state level actor, but that could attack all authorities, that could attack all authorities. But the idea is that you could never, that like to be able to attack any one authority with 100% accuracy, you would need to be able to attack all the authorities. So it's sort of like a good enough kind of thing. But I'm the wrong guy to ask about this, because my knowledge of the consensus algorithms is like all right, but yeah, not complete enough.
Okay, fair enough. Cheers.
So if I'm a developer to build something on top of Substrate, how do I need, is it bound to specific programming language or some sort of a common library which you can access from anything?
Yes. No in theory, but realistically, yes. So Substrate is written in Rust. We have this Substrate runtime library that sort of abstracts away a lot of stuff. That's also written in Rust. There's realistically not that many languages that compile to WebAssembly in any kind of convenient way apart from Rust. You have to learn Rust, basically. I mean, it's in the future, it's possible that we'll like write bindings for other languages, but there's not really any plans in the works right now. So yeah, you essentially have to write it in Rust.
So anything which compiles to WebAssembly?
Anything that compiles to WebAssembly, yeah, exactly. You could, it can be used to make a Substrate chain.
I thought this was a great talk. I just had one question, which was, I don't know if you can hear me.
I can hear you. Okay.
Yeah, it was just that, how do you see Substrate going into the, I guess, final arms of the consumer? So in terms of, I saw what you said with creating the front-end client and making it easier, perhaps even, I guess, as accessible as Coinbase was in the start. But how do you see this playing out in terms of leading to pervasive adoption, perhaps in a B2C sense?
So I would say that ideally, customers, people who are sending transactions back and forth, should never have to hear the word Substrate in their entire life. It should just be that these enable developers to create this kind of software that is really meaningfully useful for them. For example, like a sort of front-end client that is very permissionless and very secure. Like, that's useful for an end user, but they don't know that it's enabled by Substrate. Or an embedded light client that allows them to pay at a till with crypto. Like, that could be enabled by Substrate, but an end user, someone who's using the coin, doesn't need to know that that's what it is. Like, this is supposed to be an enabler for developers much more than it's supposed to be a technology that an end user could use. Is there anything else, or have you got more questions, further questions there?
No, thank you.
Okay, cool. Anyone else? Okay. All right, thank you very much.
Okay, and now for our second speaker, I'm very happy to introduce Richard Muirhead from Fabric Ventures, one of the leading supporters of decentralized protocols in London. Like I said before, if you are working on a promising new project, you might just be able to grab him before you go. So without further ado, I will hand over. Richard.
So in brief, yeah, exactly. My name's Richard. I've been struggling to build fantastic, enduring companies here in Europe. In fact, specifically from London. My first company that I started was actually under a funeral parlor on the Fulham Road in about 1995. And I say that because I've always wanted to do that rather than flee to somewhere else, because I believe there's such an incredible pool of talent here in Europe and such a fantastic opportunity to build great and meaningful things from here. And then about 10 years ago, made the transition over to the other side of the table, starting investing a little bit myself and so forth, and under the banner of Firestarter, and then worked with my partners at OpenOcean, who actually built out MySQL, and so have a very strong open source pedigree. And then together we decided that we really needed something that was dedicated to this particular space, and that thing is Fabric, and it's been around for about a year now, although we've been kind of active in investing in this space since early 2013. And I've got a couple of my colleagues here, Leslie and also Mache, if you want to grab particularly Mache to talk about the more technical aspects. So a few questions to pose. As I said, how do we unlock the power of the individual? I want to kind of emphasize that a little bit. How do we ensure that net that the technology benefits everybody more than it endangers us, without getting dramatic about it? And how do we maybe make sure that the organizational structures that result from these technologies do not concentrate power too much? All themes that are pretty surprisingly kind of recurrent in the kind of the everyday news cycle these days. Hopefully we'll kind of jump through a few slides and you'll see what we're talking about. It seems like when we have these challenges with technology, often the solution lies in technologies themselves. And so then arguably it probably lies in the most sophisticated technologies themselves, the most complex ones. Who can tell me what this is a picture of? It is indeed the Large Hadron Collider, and I can't tell you the exact number, but somewhere up in the sort of single digits, most complicated piece of engineering put together by people. But although with some aspects of decentralization sort of associated with it, predominantly a kind of top-down effort to create a piece of engineering to solve arguably an important problem. But actually, arguably much more sophisticated pieces of engineering and technology exist in the shape of cities. And these are not organized or they're not constructed on a strictly top-down basis. They're really very much built on a more emergent, bottom-up, and organic basis. There are guidelines, there are frameworks, there are, that people adhere to and that adapt and change over time. But it's a mesh of individuals, of families, of kind of little social tribes, of councils, of cities, of supernatural organizations, of charities, et cetera, that all, interoperate to produce an incredible result, which is the kind of, actually the extraordinary quality of life that people enjoy predominantly in cities. And so perhaps there's some lessons from that to think about in terms of how we might organize ourselves to solve the problems that continue to face us sort of day to day. So we think about this social fabric, pun entirely intended, there may be some lessons in how we organize the technology fabric. And so I think I'm not going to. I've just been listening to the presentation, and I think this is getting down to brass tacks, if you will, about how to build out the next phase of decentralization and blockchains. But and I'm obviously taking a kind of a broader view of what's going on and why this is perhaps interesting. But there are some reasons perhaps why this is possible now, or why there's good reason to invest your time in coming to this meetup, and in fact for us to build an organization to corral capital and a platform to support projects in this space. So we think there's a pretty fundamental change on the social side of things, so that it's not just about actually personal privacy, it's about a realization from organizations and governments that there's too much responsibility inherent in concentrating people's data in one particular place. Aside from the fact actually that if you manage it in a different way, you could well unlock more of the value of that data to greater benefit to all of the individuals within society. But I think we've reached a tipping point there. The second thing is Obviously, some technological innovation. I'm not going to start talking about that. I think people are pretty au fait with some changes that happened almost sort of 10 years ago and have been built upon since then. And then there's a pretty interesting way in which you can tie those networks and the issuance of tokens to raise capital, but also to incentivize and coordinate actors and individuals within those networks, perhaps to address problems that were previously impossible to address. Just a sort of tip of the hat to open source itself. The way we sort of looked at this when we first started coming out our thesis and what it was we thought was so exciting and tried to articulate that was that this was a kind of fourth and golden age of open source. That open source itself, of course, is this movement of distributed individuals building this software that can operate then in a decentralized way. A lot of that was built and operated at various layers of the internet in a decentralized way. But you could argue, without going through every step of this, that began as a kind of passion project, a very romantic project. There was an effort to commercialize it through service and support, which was made possible by the scale of the distribution of the internet, but was pretty hard ultimately to create successful businesses. MySQL being an exception, but perhaps even then sort of sold itself short, arguably. And that in this third phase, again, and this is a little bit the kind of enterprise level dystopian view, we have this concentration of our data and software that actually the likes of Facebook and Amazon and Google do not actually own. They just kind of sponsor a bit, that results in their trillions of dollars of market capitalization and indeed the concentration of power. And that, of course, the view is that in this fourth age, the coupling of the different factors I described before can lead to this golden age of open source, and you can really get close to the point where the only limiting factor is people's imagination to be able to code something up somewhere in the world to solve a problem that they're familiar with. And the way we look at it as well is that that aspect, being able to build these decentralized data networks and a new approach to structuring data is just a core component, a kind of central piece of icing in this cake, if you will, of different megatrends. I used to hate the whole Internet of Things kind of megatrend because it seemed sort of a bit abstract and wishy-washy, wasn't quite sure what it was. And, you can go back and forth on how enamored you are with kind of everything suddenly being AI. But it kind of makes sense as we see now what's happening. You've got, cars, watches, all of these different devices that it's possible can produce a lot of data and that are in touch with us on a day-to-day basis and can therefore have data that is very much related to our daily lives. It's very intimate to us. And then on the other extreme, you've got algorithms that would like to get their hands on that data and hopefully do something useful and deliver back to us what we kind of dub a kind of a very human-centric software service that knows us as well as you would ever like a piece of software maybe to know you. And this layer in the middle that ensures that is done, with the right respect being paid to privacy, to security, to scalability is a pretty crucial layer. And that's one way in which we view what's going on now with the background of faster, wireless connections and the rest of it. And it's going to lead, as I said, to, I think, a whole new generation of applications running on not just phones, but obviously every other device, and many of them invisible to us and talking to each other that we're pretty excited about. And, in short, if you take the long view, we think this is the long view you should be taking, going back hundreds of years and perhaps even more like thousands of years, because it's not just about a technological shift. This is about technology that enables an organizational shift. The top-down command and control structure you see in companies today has only really existed over the last few hundred years since you created concepts of accounting and since we shifted from a kind of more feudal, social structure. So you could argue it's actually more impactful even than these technological shifts. And if we want to kind of try and get excited about what this next wave is going to produce in terms of major companies. And maybe it's the wrong thing because we're saying that we don't like some of the market capitalization that has gone to Facebook and Amazon and Google and the rest of them. But we think that this wave of tokenization, I guess we would think of ourselves as loosely as token maximalists, that we see the potential to tokenize many, many different aspects of the relationship between ourselves and the things that we own, is quite akin to the wave of digitization that happened in the late 90s and through in that kind of Web 1.0 phase. So pretty fundamental shift. And that leads to, and has led to, an ongoing debate about, okay, you can use tokens to raise capital, you can use it to incentivize people, you could use them as money of different types, and some of those characteristics are listed out here on the slide. But how do you value these tokens, and how do you know that the way the token has been designed and the token economics of the network actually leads to value? I think this is a fresh area that is on the cusp of moving from art to science or from the designing draftsman's board to reality and getting data behind it and models being built. But we're super optimistic that combinations of these characteristics are going to lead to a very significant amount of value being inherent in these tokens that are native to these networks. But right across the board, from tokenization of existing assets through to tokens that grant you the right to do work, through to not just today's forms of digital or crypto money, but others as well in the future. And so we think that there is a kind of organizational movement afoot. We think we're pretty excited that there are good arguments to suggest that decentralization can actually, the reason this is going to be a successful movement is because of the rate at which it attracts the talent that we kind of have in this room, for example, and that we witness happening in meetups all the way around the world. I mean, it's kind of an obvious statement. It's necessary, perhaps, but not entirely sufficient. But I think you can measure the fact that there's an incredible level of interest from the greatest brains around the planet, both technically and entrepreneurially, to focus on this area. But I think also there's something inherent in so we say some level of decentralization, a change from previous organizational structures that can give people who participate in these networks better value because of the way the economics can be redistributed, but also can give them a greater sense of purpose because they're participants in making these networks effective. People tend to respond pretty well to having some purpose on a day-to-day basis. And that we think, in a sense, going back to the previous slide, that there's a huge value to invest and therefore play a part in building these out. We also think, I'm not going to go into this too much, Maciej can tell you more about it, that the role of an investor has shifted a little bit. So one warning that VCs used to give to entrepreneurs was like, when you take money from a venture capital firm, you better be ready to adapt your business model to a venture capitalist business model. And the reason for that is that venture capitalist really is looking for that 1 in 10, 1 in 20, 1 in 30. And so you're going up to bat and you're swinging for the fences every time, actually trying to take more risk than most entrepreneurs. And so you better be ready to do that if you want to be someone who's funded by venture capital. But in this case, actually, there's some adaptations required to participate in these networks. That means, I think, that venture capital has to adapt its model to participate in these new networks. So it's kind of flipped around a little bit, and it'll be interesting to see how that unfolds. We are investors in Polkadot in a very small way. We're supporting supporters of Polkadot. We're trying to support Web3 also. That reflects some of our kind of investment thesis that we think that we are still at a relatively early stage and that building out the technology that the stack, if you will, is where the main focus should be at this point of time, and that we'll get to the super exciting, sexy for your average person on the street or your grandmother, or even if she's very technical, applications over time. And the dApps will be exciting when they're no longer dApps, they're just apps and people want to use them. And, you know, Polkadot has characteristics that I think are a good reflection of what we're generally looking for in great projects. So, you know, that you've got a super bold vision. You are someone who, you know, you've got a team and a project that really may be starting small and acting quickly, but really has a very big vision of how big the project could be, how big their company could be. That obviously and evidently has a fantastic team going from, you know, the people assembled here through to, you know, Gav Wood and Jutta and so forth. That's you know, absolutely key to what we tend to be looking for. And that the product itself, the vision of where to start, we think this is, you know, a key part of this vision of many different organizations using blockchain, using decentralization in an interrelated fashion to build up this new kind of social fabric that is actually quite hard to kind of totally get your head around, but I think is going to do some good things. And that was me. Thank you very much. I don't know how time is, but I'm happy to answer questions if there are any.
Great presentation, and I like the fact that you woven in the word fabric into your into your presentation quite frequently.
You mean I should do it more?
No, it was good. I loved it. So bringing it back to what you said around how in the previous world, Web 2.0, you had the startups having to mold the way they do things to cater for venture capitalists, and now in this new world, Web 3, it's the other way around. Now, in the old world, you'd have investors, like you said, 10x returns, whatever, and they'd have to, you know, bet on a bunch of different horses and make sure that one horse is $1 billion company. Now that you know, these tokens are more liquid, how does the economics change for venture funds like you?
Oh, it's an exceptionally good question. So it's a combination of things going on there. So just off the top of my head, first of all, I guess when you come to a project, some of the things are the same, you know, big vision, you know, the team and so forth. But some of the things are different because, of course, there's different ways potentially of accessing capital. I mean, I think obviously it's not the same as it was a few months or a year ago, but we're not thinking that the potential to raise money through tokens is going to go away. I think it's going to sophisticate. So that's a different factor in thinking about your business model as a venture capitalist. I think we've toyed in my mind, and we've had chats about, is it possible that when you're investing more in kind of ecosystems and communities, that you have a different failure rate, a different kind of downside as well? So it's not going to look the same as the failure rate in a company. For example, you don't have necessarily the same kind of co-founder risk because there's a more inherently decentralized team and community building the software. And there are already projects like Bitcoin and, you know, and Monero, I believe, for example, that don't have the original founders developing it anymore. So I think that changes the nature of it. And then, as you mentioned, there's the liquidity question. So if you can get your money off the table, and that means other people can come in and support the price of the token, and that means the thing can still work, should you turn your money quickly? And I guess the net of all that is that we can see those factors. We still think that a great part of our proposition is being a patient, diligent, long-term investor, partner to the entrepreneur, because at the end of the day, normally great things just take a long time and there's lots of ups and downs. But it feels like the model is going to be different, but we just don't know yet. Sorry if that didn't...
No, that was a good answer. Thank you.
So, like, you seem quite excited on the token model, but token model kind of came out only for the last couple of years. What's your thought on the blockchain project without tokens?
Yeah, fair question, and we should probably get the balance better in those slides. So, I mean, maybe a better way of putting it is that we don't care whether it's tokens or equity or, a kind of long-term convertible note or whatever. I guess we just said, look, we'll be totally flexible and try and understand where value is going to accrue and how do we best capitalize the project to do what it needs to do, including, tokens. So that's and including, of course, doing equity that leads to tokens. Any more questions? One more question.
I have a question on, as you scale these projects, and then you have different layers, just talking about governance and how the incentives, the token incentives, diverge for different parties. Have you seen good best practices at different phases maybe, and maybe it's something we could benchmark? That sounds interesting.
Look, I mean, I think there's still a hell of a lot of experimentation going on. You could argue that, Ethereum has not done a bad job of trying to evolve that over time and become, more decentralized enough to be decreed a commodity. And, and I think then, obviously you've got EOS then, which is inherently less decentralized, but it's meant to have some other advantages. Best practice, I think there's a lot of practice going on, and what will turn out to be best. I'd love to hear if anybody feels that they know what best practice is yet, but it's still early days. But it's hard to, it's a lot of moving parts fast, isn't it? Technology, organizational structure, incentives, and all interrelated at different layers of a technology stack and in different parts of interrelated applications. Hard to predict how it's going to work. I guess the point is, going back to the questions of emergent governance. If you create transparency and individuals can make decisions based on the data that is transparent, and organizations can make decisions, then this should evolve organically towards something that works. But I'm sure not without lots of ups and downs. I'm not sure that I nailed it for you, but we'll come back to governance. Any more?
What's your view on utility tokens, especially from ownership perspective as a venture fund? Because basically now there's no claim. If the project fails, there's no claim. There's no legal claim to that. And as I remember last quarter, it was 40-something% of the tokens were utility tokens. So what's your view? Do you think they're going to be going to securitization at some point? Or do you think they're going to find a new leeway or loophole? Go.
So look, I think the intrinsic or the kind of core characteristic of a token that makes it exciting is that it's kind of an infinitely programmable way of describing a piece of ownership. Yeah, and so I think, and then we try to have that taxonomy of different characteristics that they can loosely have up on the slide, and then we have a little blog post about that if you go to our kind of Medium publication. And I think in these early days, a lot of people have taken to shortcuts and said, let's say it's a utility token and kind of basically go, it's going to do some payments that are native to our network. That's pretty unlikely, or rather, but not impossible to create value, because you're saying I'm going to create a new digital currency for a new kind of microeconomy. So it better be a pretty successful one for that to have value as a means of payment, store of value, et cetera. So, but we do think that if you have more of a function within the network, if it's being staked as a sort of membership and access to discount for users, or staked by individuals who are going to be doing some work, all of these elements can add up to something that creates value, and including other types of values to be forms of security. We're not averse to that. Thank you very much.
Next up, our third speaker of the evening is Dr. Alistair Stewart. He is leading the research at Polkadot. So I will invite him to the stage. If you give him a big hand, Alistair.
Hi, I'm Alistair. I'm a researcher at the Web3 Foundation, and I'm here to talk about consensus and finality, specifically about what we're doing in Polkadot. And indeed, there's some interesting questions in Polkadot about how parachains work. I'm not going to cover those. This is just going to be about single chain consensus, so it's applicable to other systems. So just for the relay chain. And if you use Substrate, you can use this for your chain. Closer? Okay. Can you hear me now? Yeah. Right, really close. So I'm going to try and explain something technical in 15 minutes, and I'm going to lose half of you. Don't be afraid to ask stupid questions. So who here understands how consensus works in Bitcoin? Okay. I hope not to lose all of you straight away. So the question, one of the questions we're interested in here is finality. That is, when will a block never be reverted? So imagine we have a proof of work chain. Now there always will be forks. The rule is we solve some kind of puzzle to get to produce the next block. And we try and produce on the longest chain. And so how would we end up with a fork in this kind of system? So how would we end up with a fork 2 blocks deep? Well, to get this first fork, this first thing here, well, if suppose this guy produced first, why would this guy not build on this guy? Well, there's basically 2 reasons. One of which this guy might actively be trying to double spend, but we assume only a few people are going to do that. The other is that he might not have seen this block by the time he came to produce a block. And so it sort of depends a bit on how long messages take to cross the network, and compared to how long it takes to produce a block on average. But you can kind of argue that this kind of situation is actually quite unlikely to happen. Now, to get a block of length fork of length 2, it has to happen again with this block. So again, this guy has to have seen this block first, or this guy saw this block first, and if block propagation times are fast and block production times are slow, that's unlikely. And if you carry on the fork, again, we can quantify this. We can say maybe there's this percentage of guys trying to actively create a fork, and this is the block production time. This is how it works. This is how the network works, and what we get is that a block back here is probabilistically final. If we build 3 blocks on it, it's probably going to never be reverted. And if we keep on building, we have eventual consensus. Eventually, we'll all agree on the same prefix to the chain. So this is sort of what proof of work-like things do. They give eventual consensus. They give probabilistic finality. Now, this is a problem because I don't know if I used to use Bitcoin. You used to have to wait for 6 confirmations an hour because the merchants really wanted to be sure that this would never be reverted. So this isn't perfect, but what you get, the great thing about it is it's decentralized, right? In that you could have many block producers. I say potentially because, of course, there's mining pools, and in other systems like proof of stake, stake is also pretty concentrated. Potentially, we can have a lot of block producers this way. It also has this nice starfish property. Some species of starfish, if you sort of cut them in 2, you end up with 2 starfish. So if a proof of work blockchain is cut in 2, then the 2 pieces will individually, we have a network partition. Generally, this would be because of a bug rather than because North America's been cut off in its internet from Europe. But if that happened, both sides would carry on producing blocks. And And I say proof of work, but of course, many proof of stake systems, starting with Next, have attempted to emulate Bitcoin and have very similar properties. And some even quite radically different consensus algorithms sort of give something like this. But there is another major school of how to do consensus algorithms. And it starts with this property of Byzantine fault tolerance. Now, yeah, okay. I've heard, yeah, Byzantine tends to be the British thing. I've also heard Byzantine, Byzantine, all four of them, genuinely. And that's why everyone just calls it BFT. They actually called themselves Romans, so it's very difficult to know what you should call it. So we have like the traditional computer science metaphor, the Byzantine general's problem. This isn't a great diagram. So what the idea is that we have these a load of Eastern European armies surrounding a city, and they have to decide should they attack or should they attack now. You know, they need to coordinate their attack. If they all attack at the same time, it's going to work. If none of them attack, it's fine. If some of them attack, they're going to lose. So each of these armies has a general, and they want to sort of work out how to send messages, because it's not easy sending messages. It's very slow. You have to send a rider. And in order to coordinate this attack, the only trouble is that some of these guys may think that they're in charge and do what they want. Some of them may actually be traitors and tell people random things. And the question is, how do we build a protocol that deals with the fact that a large number of the actors are not playing? Now, so instead of being generals attacking a system, we could consider a group of validators coming together to agree on what the next block is. And this is sort of the approach that, say, Tendermint or Algorand agreement take. Now, I don't really have any time to explain how this works. I need another half an hour. So, you know, the only thing I want to point out here is why we have a bunch of votes in which we need a supermajority, 2/3 to vote for the same block in order to come to agreement. I want to sort of explain where does this 2/3 come from? Well, one reason is if we think that these algorithms could tolerate up to 1/3 of guys behaving maliciously. And one reason why we can't ask for more than 2/3 vote is because even if the honest guys vote, the bad guys might not turn up. So we can't go for more than 2/3. But on the other hand, we can't go for a simple majority, because these guys who behave arbitrarily, they can tell different people they voted for different things. You know, they can vote twice. Nothing stops them. And if they vote twice, that means we can have a majority for 2 different blocks. And normally these things will break when that happens. But if we require at least more than 2/3, and less than 2/3 of them are bad, then we can be sure that if we see more than 2/3, we have to have a majority of the honest guys. Right? I mean, suppose that just under 1/3 of guys are Roman, and that means that just over 2/3 of guys are honest. So half of those is just over 1/3, which is what you need to get 2/3 with a third voting for everything. And that's why lots of algorithms, lots of protocols only work up to 1/3. Anyway, so sort of how does this compare, this Byzantine agreement on every block, compare to your sort of Bitcoin-like consensus? Well, the one great thing is that we're instantly final. Right? We get finality as soon as we agree, and we only need to include finalized blocks. Another thing is safety. Even if the network is terrible, we can't finalize 2 different things. And one really important thing is provable finality. We're going to be able to generate a message signed by 2/3 of validators saying this block is valid. And this is important because this means that a system that isn't following the chain at all can verify this statement. Now, this is useful for light clients. This is also useful for convincing different chains for interoperability. It's like the reason why Cosmos use Tendermint is because it's really important for them that we can convince other chains that this is what happened on this chain. And this is also the reason why Ethereum have decided to merge Casper, which has got its proof of finality, and sharding, where they need to communicate across chains. So sort of the downside here is everyone needs to sort of send a vote to everyone else a few times. And that means if we have a lot of guys voting, this is slow. So we have a choice, either have few guys be very centralized or be slow. So I suppose the question now is, can we get all of these things in one consensus algorithm? The answer to that is no, we can't. So this starfish property, the network splits, both sides work. This asynchronous safety, which says even if the network is really bad, such as if it splits, we can only finalize one thing. So even if the network splits, we can only finalize one thing. And this fast finality, which says that we only include blocks if they're actually final, means that if the network splits, at least one of the branches is not going to do anything, not going to progress. Also, this trade-off is something I don't know is impossible, but we don't know how to get around. So what we're going to do, what we do in Polkadot is something pretty similar to what Ethereum are doing. We're going to go for a hybrid consensus. We're going to go for something we're going to have something proof of stake that's a bit like proof of work for our block production. And, okay, that didn't work. And we're going to have another separate thing, a finality gadget, another separate thing which people are going to vote on blocks and going to agree later. So we're going to have all of these properties apart from fast finality. But the trade-off is going to be we're going to have block production. We're going to have finality that's a bit slower than block production. We're going to have blocks that are not produced that are not final. But nonetheless, in the end, we're going to have provable finality. Probably faster than the hour it took to do with Bitcoin. So, how does this work? So I sort of should explain how Casper works, because Casper, the friendly finality gadget, Ethereum came up with this approach. And what happened is that we agree on checkpoints in the initial draft. So every certain number of blocks, say every 64 blocks, we have a vote. And if this goes well, we can finalize, 64 blocks and maybe more than that. So if this is, and I think this is quite nice, especially for their use case. But so I suppose I better answer why did I want to come up with a new approach to this problem? So one thing is that we can't finalize anything for 64 blocks, or 42 in the latest thing. And we need to get this 2/3 supermajority on 2 consecutive votes to finalize anything. And this sort of means we need to measure the time we wait for consensus in blocks. So you sort of need to know how many blocks is it reasonable, and you've got to be a bit generous to this because we have to get all these votes in on time. So this is one reason I want to come up with a new thing. Also, they don't give a very good separation in between block production and this finality gadget. I wanted to be make these a bit more conceptually separated, which enabled me to prove some things that they can't, and also makes it a bit easier to implement. So a lot of the things in Polkadot, they try and developers have deliberately tried to separate systems so that we can make it a bit more pluggable. So I decided to come up with a new thing, and obviously then you come up with a few things. The most important thing is what we can call it. So we had several suggestions. Initially it was Casper AFG, Polkadot Finality Gadget versus 9000, Family Tree we came up with Grandpa, Ghost-based recursive ancestor deriving prefix agreement, I think, and Shaft. Shared ancestry finality, cool. Which one should we go for? Okay. Well, at the moment, everyone's too conservative. I'm still very tempted. We're going Grandpa at the minute. But it's not final, right? We still might be convinced to change it. So I need to explain very quickly how what Grandpa does that's a bit different. So in order to sort of avoid this, the reason why you need checkpoints in Casper was because you kind of have to vote on blocks of the same height. Because if you're going to get a 2/3 majority, it's no good for one person to say, even if everyone agrees on the chain, someone might see this block and someone might see the next block. So I wanted to deal with a situation where, so suppose we have 30% of guys voting for this, 40% of guys voting for this, and 40% of guys voting for this. And then we kind of have like 70% for this chain and 40% for this chain. And so the way we're sort of going to do this is I'm going to sort of consider that let's run a Byzantine agreement algorithm on every block number simultaneously. And let's count these votes as for every block before them. So we don't vote on blocks, we vote on chains. So if we see this distribution of votes, then we can sort of add them up and get this sort of distribution on blocks. So we have 70% for this chain, 100% for this. And so for every vote, for everything we have a 2/3 vote. So this is something we get for a single 2/3 vote. And we'd add up things that can get something like this. And the important thing here is that, these blocks will get a 2/3 vote at that block number. And the important thing here is that if a block had 2/3, then so must all blocks before it, because every vote for that block is a vote for something afterwards, and it will count for everything before it. And also, these 2/3 votes are sort of guaranteed to have a unique winner if only 1/3 of people were voting twice. And what that means is that basically we agree on a chain. So we sort of do this for each of the 2/3 votes in our algorithm. And the protocol, and we put all this together, and we basically end up with something where we agree on whichever prefix 2/3 of honest guys agree was the best chain, including whatever was finalized or we were agreeing on. And that in 2 minutes is how Grandpa or Shaft works. Thank you. Any questions?
Okay, that's good. Do all the validators need to be known beforehand, before they run? So it means.
Yes, we need to know who all the validators are. Yeah. Of course, this is going to come from the chain eventually, but sort of the idea is that we'll already have finalized this block by the time we get to change the validators yet, hopefully. We do sort of have some contingency plan for what happens if a third of validators go offline. Because block production is going to carry on, we should be able to recover from that in a kind of non-safe way. And yeah, that's one of the advantages of doing it this way.
Is there a well-established procedure on how to rotate the set of validators? Like in 10 years, for example, like half of them will be like non-existent. Like how do you include new ones? And
so actually, yeah, this is one different thing about this algorithm, is that you could just rotate validators, in that even if you have a different set of guys for every vote, it still works. But the trouble is you have to sort of agree on what the new set is, and that you can only basically do on chain, sort of having finalized it. But yes, it's good. I think we have a much cleaner way of dealing with rotation of validators than, say, Casper does.
Any more? There we go.
How does an honest validator decide which block to vote on?
Right. Well, if so the one thing is you need to be able to sort of overestimate what we've already agreed on in order to get safety, and we have a procedure to do that. Sort of look at previous votes, and once you've done that, you basically that fixes a block which may or may not have been finalized or might be finalized, and you vote for the longest chain including that block. That's be the canonical thing to do. So if we vote for the longest chain including the last finalized block, then unless we finalize something new, we're going to have eventual consensus. We're going to have probabilistic finality because that's what our block reduction does, and that helps us to agree on a new block.
I think we're going to have to leave it there, guys, because we've got our final speaker of the evening. Thank you very much, Alistair. Big hand.
Hi, everyone. I'm Francesco. I'm CTO of Applied Blockchain and tech lead of the Fern project. So as Applied Blockchain, we found essentially a problem in proof of authority networks mainly. And that's why we came up with an authority selection for a process to avoid essentially providers of block providers collusion. So authority collusion. I'll show you briefly because I have 15 minutes only. A POC that we done open source by Jimmy Chen, which is in the audience, blockchain developer, and over there. And then we are using a ring signature library, both Python and Solidity by Harry R. You can find both via the GitHub username, and then we have the POC in that bit.ly Fern Polka link. Oh, sorry. So we are Applied Blockchain. We are a dev shop based in London and Porto. We are around 25 devs, most of them with blockchain experience. We do like 95% Ethereum applications, and yeah, essentially I'm a bit of a Bitcoin maximalist. I would say I'm like 95% Bitcoin maximalist, even if I think Ethereum is pretty okay. And of course, Polkadot and Parity and Substrate are great technologies. But yeah, most of the clients that we have actually ask for private blockchain development because of scalability and because big corporates are afraid of touching cryptocurrency. But yeah, let's not talk about that because I don't have much time. So okay, so that's the main thing. That's the thing we want to cover. So how to secure your private chain, how to secure your chain against collusion attacks on authorities. So I want to explain the problem. I want to give a bit of a hunch what's the Polkadot and Substrate integration of Fern, what are ring signatures very briefly, and what is our smart contract based solution. So the problem is that if you have most of the authorities colluding, then you can basically stop people from transacting, and you can essentially, I don't know, get you more ETHs or get more rewards depending on how is your scheme and services on your POA chain. We had a recent EOS Huobi mutual voting, I mean, news and report, which wasn't very good for EOS. And yeah, essentially we are essentially trying to solve this by selecting, randomly selecting authorities from a pool of verified service providers, like service providers that have already been verified as like software companies, but then in your chain you get used, I don't know, let's say 10 of them, and you don't know who they are. And essentially nobody can bribe them. That's the main point, because they are anonymous. So probably you have seen about Polkadot integration. Probably you have seen this diagram. It's a very clear diagram. Everyone can understand it. But yeah, I won't go into the details because I don't. I mean, Polkadot is pretty complex in itself. But essentially, where Fern sits it's like on the side of this thing. So on the side of Parachain, which is POA, or I mean Substrate with link to Ethereum with an authority consensus, which is not ready but should be ready soon, from what I heard, yeah. And yeah, essentially sits on the side, providing authorities, and hopefully, even if Polkadot already provides security to parachains, at least you can have a proof of authority chain with like authorities that cannot collude. So also Fern is tackling another problem, like quality, not only collusion, so also reputation. But I won't talk about this. Yeah, that's the intro. So in 10 minutes, I'll try to explain ring signatures and our solution. So what are ring signatures? So ring signatures is, I mean, in 2 words, is the one that Monero uses for confidential transactions. What they do is essentially an advanced public key cryptography tool, and these are the steps. So you have a list of public keys, essentially of a group. So usually, I mean, at least in this case, different parties, so different people have, each of them have a public key, and ring signatures say that if every key signs a message, you can still verify the signature is valid, but you don't know the public keys, I mean the private keys corresponding to that public key that actually signed that specific message. And we don't actually only use this. I know it's very strange, but this is like a zero knowledge proof, but it's probably the easiest one. But it's already complex to understand it. Compared to like normal public key cryptography, and we don't use those, but we use an extension to that, which is linkable ring signature, which have everything in that list. So essentially, you can verify that the signature is valid, but you don't know who is the key that signed. Plus, you have this property which each key can sign a specific message only once, and otherwise they will essentially the message will be spotted that that signature is the same. So they will have like an identical tag. So this was very fast on ring signatures. Probably you can ask me more questions later or even later. And about Fern, so essentially to solve this problem and to give essentially these anonymous block providers, we want to give these providers, these authorities, 2 identities, so 2 sets of public and private keys. One which is an open one, and that will be associated to actually their identity and some like proof of who they are, and an anonymous one, which is the one actually used to seal blocks and to do transactions like ethers or tokens transaction on the parachain or proof of authority chain. So yeah, these are the bits in the puzzle. Essentially, we have the 2 keys, an anonymous one, an open key. We have all the open keys forming a ring. So every time some key, essentially, whenever they sign from the ring, you don't know the exact key that's signed. And then we have a certification, some like signatures for either block providers and ETH and token transfers. And essentially, the open key is just signing with a normal signature by a single private key with no ring, their certification to say who they are and which service they provide. And we have an anonymous key, which is actually the one used for ethers, tokens transfers, and signing blocks when they're doing their authority. And then we have essentially the ring. The ring is used to associate each anonymous identity to a specific group of open keys. And that's done via some ring signature magic plus Ethereum smart contract. So I'll skip. You can find the open source code on this URL. I will tweet and I will let Applied Blockchain also tweet. So if you follow me or Applied Blockchain, you will see this deck with the links. And yeah, we start from a smart contract, Ethereum smart contract Solidity for now until we have WASM. And essentially we put a group ID, so like a list ID, a list of like an open list where we have a set of public keys that can register in, and a number of parties with this number of open keys in the ring. And what they do is they use their key to do a ring signature to say, I am part of this list, but they don't publish it to the contract just yet. Because we want to associate it, how we actually associate it. So first, we get their private key, and we let them essentially sign a message that's saying, like the address of my key is this, and we put it in the smart contract, and essentially there is a problem if everyone does that. People can snipe the transaction. So what we do before, we actually do a hash of it. It's actually has a specific name. Maybe Jimmy can help me. Commit reveal partner. So essentially we do a hash of the address, we publish it to the contract, and then when everyone already committed the hash, then they can send their signed message with their address, and in that case we will validate the hashes at the smart contract level, and we will make sure that nobody essentially put like signed twice, or another party that has not signed with the ring signature key is not like joining this list. Because otherwise, if you have the same party signing twice, then there's a possibility of collusion, essentially. Yeah, and essentially the ring signature gets verified as smart contract level, and all this is all thanks to the library by Harry R, which is called Sol Crypto. So mad props to him. And yeah, I know it's has been very, very abstract, but yeah, that's the way we achieve essentially anonymous providers on POA network. And of course we need a network layer. We'll work on a network solution. We plan to use something from Monero networking, or probably an extension to libp2p, or something alongside the onion routing, but we are not there yet. I will skip the code part. So this is the smart contract code. Essentially, probably I just show we are using Harrier Sol Crypto library to verify that the ring signature is valid, and we have maybe a short, like I'll just show you a short video. So if I just drag it, sorry, I'm giving you the back. So I'll just essentially, if you play with the repo, if you're a coder, you can play with this command line tool that we build, and using Ganache or Parity, you can essentially deploy the contract to your local testnet, create the contract, generate the ring signatures, get a list of public keys, and sorry, I should finish soon. And yeah, essentially do the process that I explained you, and that's already ready for actual chain usage. It's a bit costly to verify the ring signature, but yeah. That's it. We don't have time for questions, so mad props again to Jimmy and Harry R.
Great, thank you very much, Francesco. That was very insightful and topical. Thank you to all our speakers, actually, for this evening, and thank you to everybody for coming. We are out of time, so I'm afraid we can't stick around for drinks, unfortunately, because we need to tidy the place up. So I'm really sorry, but we're out of time. We'll be back on the 14th of November for a panel discussion titled "Are Parachains Better Than Smart Contracts?" So if you are around on the 14th, please come along and we'll see you then. Thanks very much.